Here we're asked to solve the equation by completing the square and state whether the solutions are real or non-real. So first things first here is when we're doing completing the squares, we draw a square or a box, and then we are putting the first term in the first box, and then we see that there's an issue with this because the next thing that I want to do is split the second piece in half. But the issue here is that when I'm trying to figure out what goes on the outside, if I have a negative number to start, like I can't do x and negative x because now those aren't the same, and that kind of defeats the whole purpose of completing the square. And so I actually want my a value, or this first term, to be positive, so I can either add all these things here to the right side so that it's 0 equals and then all the positive values, or I can multiply both sides of this equation by -1. Either way, what that will make it be is positive x squared plus 6x plus 11 equals 0. And now that it's positive, now I can kind of move forward with my completing the square because my first term is x squared. And so we can now split the second term in half, figure out what goes in this last box, because again, we want the sides to be the same here. 3 times 3 is 9. The issue now is that 9 is not equal to 11, so we need to figure out how to make that equal, which is why I'm going to take whatever I get from that and add 2. So finally, I've now made my equation equal to each other. I see the box gives me x plus 3 squared. I add 2 at the end, and now I can solve. So I'm going to go ahead and subtract 2 from both sides. X plus 3 squared equals -2. I'm going to take the square root of both sides. When I do this, I see that I get a square root of a negative, which I'm going to pull out and just call that I. And lastly, I'm going to subtract 3 from both sides. So x equals plus or minus I root 2 minus 3, or you could rewrite it as -3 plus or minus I root 2. And either of these two answers would work, really, just whatever looks neater to you. But in this case here, since we have that I, we know that both of our solutions are non-real solutions.